and welcome users to my channel Learning with Khataka. In the last lectures, we covered the basics of neural networks and why we called it artificial neural networks. We basically look at the basic structure of human brain to look at the structure of neurons, how different neurons interacting with each others in the human brain, and then in artificial neural networks these neurons are basically replicated to form artificial neural networks. And then in the first lectures we cover the different layers of the artificial neural networks, that input layers, hidden layers and output layers. Hidden layers depends upon the problem complexity. There may be one hidden layers or more than one two hidden layers, and how different inputs are come to the input layers, and how these input layers process these inputs and then process to the next layer. Similarly, we also cover the basic terms used in human neurons, brain neurons, and then artificial neurons, artificial neural networks. This is the node, and then how different inputs are come to the node, and how nodes process these inputs and then output to the next layer. So in the last lectures we stop our lectures at the activation functions. That is very important part, important topic used in neural networks. In today lectures we will look at the different activation functions used in neural networks. We will try to implement all these activation functions in the Python by classifying classification problem. Second more important thing is, since the activation function is important part of a neural networks, artificial neural networks can be used for a classification purpose and for regression purpose. We can use neural networks, artificial neural networks for binary classification and for multi-class classification, and even for the image classification using by deep learning network. So if you look at the slides, this is simple neural networks, and this is the weighted sum, and here is the activation functions, how these activation functions, some mathematics behind the activation function, different types of mathematic activation functions will be discussed in this lectures. So this is basically the last slide of the last lectures, which is here the input value 1, input value 2, and input value m. So means these are the different input values, and this is a node. This is a node or simple neurons. In artificial neural networks, we call every neurons is represented as a node, and this in the inside the node, if you look at the equations or some mathematics, this is basically represent an activation functions. Now what is this activation function? Let me define first, and then we will come back to this slides, to the diagram. So an activation functions decide whether a neuron should be activated or not. What does it mean? This means that it will decide whether the neuron's input to the network is important or not in the process of prediction using simpler mathematical operations. So what does it mean here? Now these are the different inputs come to this node. These inputs are augmented or combined with the different weights, and then inside this node the activation function decide whether these inputs will be processed further or not. There are some criteria that how activation function will decide whether these inputs will be processed. Fired means will be processed to the next node or not. So so what you have to notate that activation function is basically used to decide whether the neuron's input to the network is important or not. And then the role of the activation function is to derive output from a set of inputs valued feed to the node or a layer. So if you look at this slides again, diagram again, and then the role of the activation function is to derive output from a set of inputs value feed to the node. So means these are the input values feed to this node, and then activation function inside this node will decide to further proceed or not based upon some criteria. So is to derived output. And then what is a node? What is a node? A node is a replica of a neuron that receives a set of input signals. As we discussed in the last lectures about the human neurons, that a human neurons can accept multiple inputs from multiple ways. And then similarly in the artificial neural networks, a node is a replica of a neuron that receives a set of input signals. How this is? If you look at this, this is basically artificial neurons, human brain neurons, which is basically this is cell body, and this is the dendrites, which gives inputs from different means. This is the nucleus, and then these inputs are processed here and then proceed via the axon to the axon terminal. If these inputs are important, then this neuron will proceed these inputs as an output to some other neurons. If they are not important, simply these dendrites will accept these inputs. The neurons will process these inputs. If these inputs are not important, then these inputs will be discarded here. In the same way, this is the node, and these are the different inputs: input 1, input 2, input 3. These are the different inputs like dendrites. These are the inputs come to the this neurons, this node, and this node here is the activation functions. This activation functions decide whether these inputs are prominent or not, have some important or not. If these inputs have some important based upon some threshold value, then the input of these will be combined, sum up, and then applied some weight to these inputs, and then the activation function will decide whether these inputs will be forward to the next layer, to the next node, or something else. So this may be a next node, this may be a next layer, or this may be even an output layer. So this is basically a node and a neurons. A node is a replica of neuron that receive a set of input signals. So if we look at the first slide again, now look at this. These are the different inputs to this node. These different inputs are weighted by some weight. Some weights are assigned to these inputs, and then these inputs are processed here inside this node via activation function, and then activation function decide whether these inputs are have some important or not. These inputs should be triggered to the next node or not. So this is basically what activation function works on. So let's start again. Then if this is the different inputs x1, x2, x3, these are the different weights assigned to these inputs. These are the inputs and these are the weights, and then z is equal to from I up to how many inputs are there. For example, there are 3, so I is equal to 0 to I is equal to 3. Wi, these are the individual weights of each inputs, and then xi are the inputs, plus b is basically the bias, as we discussed in the last lecture. And this is the fz, means the activation function is activated, and then this is the activation function. Then activation function decide whether this input sum, which comes from the three different which combine the three different inputs into a single input, and then activation function will process this input either to forward or not, either to trigger or not. So depending on the nature and intensity of these input signals, the brain process them and decide whether the neurons should be activated, fired or not. This is basically the phenomena of neural networks inside the brain, that based upon the intensity and nature of the inputs, the activation functions, the brain process them. Means in the brain there is a replica of activation functions which decides whether the neuron should be activated, fired or not. So now there are different types of activation function used in the neural networks. Depend upon the nature of problem, depend upon the classification problem. Either the classification problem is of binary nature, or is of multi-class classification problem, or multi-level classification problem, or related to some image problem. Based upon this nature of problem, we will use activation function. So different activation functions, for example, this is an activation function which is binary step function, which is also called a binary step functions, only be used for binary classification. Why we used it for binary classification? Let make it clear. So this is basically x-axis, and this is the y-axis. This is the value 0 and this is the value 1. So binary step function depends on a threshold value that decide whether a neuron should be activated or not. So basically, if we look at this purple line, as long as the inputs is below a certain threshold, this is a linearly distributed over the x-axis. But as long as the value cross the activation limit, the threshold value, then the nature of the curve, if you look at this, give me some other output. So if this is a simple activation threshold function, it gave me 1 if x is greater or equal to 0, means if the input value is greater or equal to 0, it is 1. If it is less than 0, it is equal to 0. So if you look at this, this values is basically is less than 0, but if, up to this point, the value now becoming greater or equal to 0. Then if this is greater or equal to 0, it gave me 1. So because it only gave me one of the two output, 0 or 1, that's why we called it that threshold function or binary stepwise function is only used for the binary classification. Now the input feed to the activation function is compared to a certain threshold. If the input is greater than it, then the neurons is activated, else it is deactivated. So means if you look at this, for example, here a threshold value is 0. If the input value is greater than 0, then the neuron is activated and it gives me output is equal to 1, and else other in other case it is deactivated, meaning that it inputs is not passed on to the next hidden layer. So in simple real life examples, if you put your hand on some iron, etc., or any heated thing, and you decide a threshold value, what will be threshold value here? If you feel more heat, unbearable heat, then you lift these things and leave it to there. So basically the nature of heat and the presence of heat is the threshold value. You place your you place your hand on this heated thing unless and until you feel the pain. The pain level is basically the threshold value. Here in this case, the threshold value is defined as 0. If the input value is greater than 0, then the activation function is activated, then the neuron is activated, which give me the output of 1. Else in other case, if the input value is less than 0, then it give me a 0. So for threshold functions here in this case, the threshold value is defined as 0. So this is the very basic activation function. Binary stepwise functions are sometimes it is called threshold functions, used for binary classifications. We cannot use this activation functions for multi-class classification because it gave me only two outputs, 0 or 1. Okay, now this is basically what the activation functions here. Softmax function, softmax function is also called the activation functions. If you look at this, let's understand how activation function works. Here, this is the activation functions, how this activation function works. In the input layer, this is basically the input layer. In the input layer of the neural networks, inputs are delivered into the neurons. Different inputs are delivered to the neurons. This is basically a neurons, a node. Each neuron has a weight. If we look at this, each neurons different inputs, and different inputs, each inputs to the neurons has a particular weight, and multiplying the input number if we look at this, weight is multiplied by the input number by the weight of each neurons yields the neurons output. So this is basically the weight is multiplied by if you look at this, input number by the weight of each neurons, and then bias is added, and then this is give us an output. So this output which is then passed to the next layer, consider this is a next layer. So to the next layer and so on. Why weight? Weight plus input plus bias. Weight plus input plus bias can be used to express the outcome. Acha, if note that y's range might be anywhere from infinity to infinity. Infinity to infinity, we must feed the values from the activation function into our desired prediction or generalized result in order to get the output into the desired prediction or generalized results. The activation functions act as mathematical gate. This is just like a mathematical gate. Some values are coming from the node, from the from the nodes, and then the gates will be decided if the gate should be opened or not. Means depend upon some threshold value, either the inputs value or the output values should be passed to the next layer or not. So this is the very simple definitions or simple explanations of how activation function work. Activation function is just like a mathematical gate between the current neurons input and its output. This is the input to the current neurons and this is the output. So if you look at this, this is the gate. So activation function is just like a mathematical gate between the current neurons and the output of this neurons. Which is sent to the next layer. It could be as simple as a step function that turns the neuron output on and off based on the set of rules of threshold. Very simple, depends upon the threshold, it either be set to 0 or 1. So this is a very simple explanation of the threshold activation functions. That activation function is basically a mathematical gate between the current neurons input and the output of this neurons. Similarly, this is another activation function, linear activation function f of x a. If you look at this, the function does not do anything to the weighted sum of the input. It simply splits out the value it was given. Means if the input is given to this activation function, then this simply proceed these inputs as a output. There is no change, there is nothing to do with the weights. That's why rarely we use the linear activation function. And this is non-linear activation functions. There are tens of non-linear activation function. The one important activation function, non-linear activation function, is a sigmoid functions. If you look at this, sigmoid functions give us values between a range of 0 and 1. 0 and 1. So how it works? So if you look at this, let me explain first. This function takes any real values in input and output values in the range of 0 to 1. So if you look at this, this is 0 and this is 1. So if you look at the output is value is in the range between 0 and 1. Now, how this curves change from here from x-axis to the y-axis. Look at this. The larger the input means more positive inputs, the closer the output value be to 1. So it means that from input start from here, we can say that up to here this point the input is not positive or rarely positive or means negative. So that's why the output value is closer to 1. But from this point the input value becoming more positive. That's why the output value is nearly closest to the 1. Whereas the smaller the input, more negative, the closer the output will be to 0. So we can say that here in this case from here to here the input is smaller, means more negative values are there here, and when the values become positive, these functions get closer to the 1 to the values 1. So this is the sigmoid activation functions. Mathematically it expresses as 1 divided by 1 plus e minus x. Similarly, there is another important activation functions, hyperbolic tangent. It is also called tanh. Mathematically it is expressed like that. What is tanh functions? If we remembers the sigmoid functions, the output values are in range of 0 to 1. So means most of the time sigmoid function is also used in the binary classification problem. But if we have range between -1 and +1, Tanha function is very similar to the sigmoid logistic activation functions, and even has the same S shape. If you look at the shape, same S shape is the sigmoid functions, with the difference in output range of -1 to 1. So if you look at this, this is basically start from -1 to +1. In Tenha, the larger the input, more positive, the closer the output value will be to 1, whereas the smaller the input, the closer the output will be to -1. Again, the same thing like, so one difference between the tangent function or Tenha functions and sigmoid function. Sigmoid function is usually used where we want to predict the output, because if you know the predictions, if you use the predictions are probabilistic predictions, where probability lies between 0 and 1. So where there is a probabilistic predictions, we have to use sigmoid functions, and when there is no probabilistic predictions, then we have to use the Tenha functions. Again, the larger the input means if more positive values, the output value will be closer to 1. So if we look at this, up to this point the values are negative, a smaller value. With the smaller value, it is closer to -1. With the more positive value or larger value, it is approaching to the +1. So this is the mathematical equation or Tenha functions. Similarly, this is another representation of Tenha functions, which is start from, if you look at this, x-axis, y-axis, minus, if from this point, if you look at this, this is x-axis, -5, -3, -1, minus that. So it means here from this point up to the middle center point, the activation functions gets a smaller value, but here from this point the activation functions gets the positive or larger value. So that's why it approaches to +1. The output of the Tenha activation function is zero centered. Zero centered means, hence we can easily map the output value is strongly negative, neutral, or strongly positive. Because if you look at this, zero centered means if the values are below the 0, it means the output values are strongly negative. If it's exactly on the 0, we say that the output values are neutral, or if the values are approaching to +1, then we can say that the output values are strongly positive. Usually used in hidden layers of neural networks, as its values is between -1 to, therefore the mean for the hidden layers comes out to be 0 or very close to it. It helps in centering the data and makes learning for the next layer much easier. So it means if there are multiple hidden layers, if you want to deploy multiple hidden layers inside the in artificial neural networks, then you must use the Tenha functions, because Tenha function at each layer make it easy processing for the next coming layer. Similarly, this is another very important functions, the ReLU functions. It is also called the rectifier functions. What is ReLU functions? The main catch here is that the ReLU function does not activate all the neurons at the same time. So very important point to be noted is compared to the Tenha or sigmoid function, or even to the binary functions, that both in sigmoid and Tenha functions, all the neurons should be activated or not. Means every neuron should be checked to activate or not. But in case the ReLU functions, the main task, the main working of the ReLU functions, that does not activate all the neurons at the same times. Means depends upon some certain values, it decide that which neurons should be fired or which neurons should be deactivated. The neurons will only be deactivated if the output of the linear transformation is less than 0. So means, since if you look at the values, it may be from -1 to 1. So all the values that is greater than -1 and less than 1, less than 0, all the activation functions or all the output values between -1 and 0 will be deactivated. Since only a certain number of neurons are activated, the ReLU function is far more computationally efficient when compared to the sigmoid and Tenha functions. Because in the Tenha and sigmoid functions, every output values will be checked to find or not, but here in this case a simple checkpoint will be there, that if a value is less than 0 it will not be activated, if the value is greater than 0 that will be activated. So this is basically the reload functions, because if you look at this, the value is -1 is minus from here this point, so this output value is not activated, this output value in the neurons is not activated, but as long as the values become greater than 0, the activations functions, the neurons activate, the activation functions activate these inputs and give it to the next coming layers. So these are the different activations functions: unit, step, headwise, signum, linear, pairwise linear, logistic, hyperbolic tangents, reload, rectifier, and etc. And these are the one-dimensional graph that if you look at this linear functions, this is gives input and same output will be there. Similarly, if you look at the sigmoid function, so this is the sigmoid functions, -1 and 0, and perceptron variant. This is the for example we can use it in a perceptron variant, and then this is used in a support vector machine, logistic regression. These are the important things: hyperbolic tangents and reload functions, which is used in multi-layer neural networks. Both the three functions is, this is basically the sigmoid the activation functions. This is the reload, and this is the hyperbolic Tenha functions, which if you look at this, this gave me a 0, means don't activate it. Here the activation is based upon the values, and here the activation is based upon the central value, less than 0 don't activate, if greater than 0 then activate. So now if you look at this, these are the input values to this node, to this neurons, augmented by different weightage. Different weighted are added to these inputs, and then this is the sigmoid functions, and this is the output. Now assuming the DV is binary, for example, the derivation problem or the problem classification problem is binary problem, then the y will be definitely either 0 or 1 if threshold activation function. If you are going to use the threshold activation function, then the mathematical equation will be like that: I is equal to 1 to m, and then weight multiplied by the inputs, the different inputs. And if sigmoid activation functions, we can also use a sigmoid activation functions, so this will be the activation functions. Again, Py is equal to 1 if the output is equal to 1, means it belongs, the input is belong to class 1. Then the sigmoid, the activation functions will be look like that: I is equal to 1 m w and that. So this is basically, now you can map the different functions, if you are going to use the threshold functions or sigmoid functions, how they will look like and how they will behave in a neural network. So similarly, these are again the inputs layer, and this is the hidden layer this time, and this is the output layers. And now each if you look at these inputs, every type of inputs are transmitted to the hidden layers. In this hidden layers there is an activation function, and then these activation functions based upon the natures, if you are going to use sigmoid functions or threshold based functions, either these inputs will be triggered to this output or not, depends upon the activation function output. So if you look at this, there is activation functions, and there may be possible that there is also an activation function used at the output layer also, which decide that whether the inputs belong to class 1 or class 0. So these are the different kinds of activation function used in sigmoid, reload, tenha, softmax, leak, and swash. Is sigmoid activation functions maps any input to the range of 0 and 1, producing an output that can be interpreted as a probability. So if you want to predict, if our prediction is based on the probability, then we have to use the sigmoid function and reload functions. The reload activation function sets any negative input to 0 and retains positive input unchanged. This function has become widely popular in deep learning due to its computational efficiency and ability to avoid the Washington gradient problem, because as we discussed in the Relo diagrams, that this is basically provide efficiency for the next layer. And so you can read these functions from here, and you can also then go to the Google's or the respective website to grab more information about that. So thank you very much. So in the next lectures, we will try to implement all these activation functions inside a Python by classifying a problem, a classification problem, that how to use different functions inside a classification problem by implementing practically in a Python. So thank you very much.